Okay, welcome to class 13. Today we're going to look at Python functions, and I'm going to get you started on the most recent lab where you're going to finally get to write a complete working game. So let's go and get started with class 13 here. So class 13, Python functions. So functions, we've been using functions throughout the semester, really since very early on in our first Python program we ever wrote. So some functions we've used: print, int to convert something to an integer, float to convert something to a float, chr to convert a number to a character, ord to convert a character to its ASCII code, input to prompt the user for some information and have them type something in and hit enter. And then we've used functions from other places like random.randint, time.sleep, pygame.init, pygame.draw.circle. Those are all functions. You'll notice one thing they all have in common are these parentheses afterwards that we use to send information to that function. So what is a function? A function we'll get to in a second, but first I want to review what a variable is. So a variable is a name for a data object stored in memory, like x equal 10 or name equal player 1. Well, a function is very similar in that it's a name that we're giving or that has been given to, but rather than some data object stored in memory, it's a name for some sequence of instructions, kind of like a code recipe or a named mini program that we can call upon to have happen. Or like you can think of like a spell that conjuring this magic spell causes this action to happen. So I say Expelliarmus, it has some meaning and it takes some action, gets caused because of that. So notice that's a little bit different than a variable. It's still a name associated with something, but it's a name associated with an action that the program is going to take, rather than a name associated with some passive data like we have with a variable. But similar concept. Okay, so what's a function? A function is a name for a sequence of instructions, like a code recipe, or a name for a spell that actually causes an action to happen. So a function is a named block of organized code that's used to perform some useful action. And we can use functions that are built into Python, like chr, print, input, str, ord, other things like that are built in. Or we can use standard library functions that come with Python, like random.randint, time.sleep. Of course, we'd have to import those modules first to use these functions, but they're there and we can import them and then use them. Or we could use functions from third-party modules like Pygame, where you download Pygame, you install it, you import Pygame, and then you can do pygame.init, pygame.display.setMode, pygame.display.quit, pygame.display.update. You'll notice that you can use all those. We can also, and this is what we're going to focus on today in today's class, we can write our own user-defined functions. In other words, we can create our own function that does what we want it to do rather than relying on something that's already in existence. We can create our own function, and then if we want to, we could actually collect a group of those functions all together and create our own library of functions. So we could make our own module, just like Pygame or random or time or whatever. We could make our own thing for whatever game we're writing or whatever project we're working on. We can make our own module. Okay, so to create a user-defined function, the first step there is to kind of define it. And the way you define a function in Python is you say def, you give it a name. So this is us giving it a name. In this case, the example is my func. You need these parentheses and then a colon. And then indented underneath that is the sequence of instructions that you want to be associated with that name. Now this is defining my func as whatever indented lines of code we have underneath there. And inside this indented code, you could have variables that you're creating. You could have if statements. You could have while loops that repeat something over and over again. You could have if statements inside of while loops inside of if statements. So this is kind of like its own mini program that's indented underneath this my func name. And that code is not executed when the function is defined. We're basically just saying, hey, create this recipe, my func, whatever it is. It might be like fire lasers. And this is what I do when I call that function. But defining it does not take any action yet. We're just defining it. So to use the function, we have to call it or invoke it. And the way we do that is somewhere in our code, we would just, after it's been defined, we would say myfunc and then put parentheses there, and that would invoke or call that function. So the same thing that we had with other functions we've used, they have to be defined before they can be called. So in other words, with pygame, to call pygame.init, you have to first import pygame, which has the definitions in there, and then we can use it. And in our case, for making our own function, we have to define it somewhere at the top of our program before we call it somewhere towards the bottom. Okay, the next step here that we need to look at is, before we actually get a little further into how functions work and how to define them in different ways, I want to talk about why. Why would we use functions? Because really, why indent this and then call it when I could have just cut and pasted this when I wanted to do this in my code? Now, there's a number of reasons for that. Let's take a look at some of them. First one, code reusability. In other words, if we want to eliminate redundancy, meaning repetition of something over and over again, we could write a function once, and it could be, that function could be 1 line or 10 lines or 100 lines, and then we could use it over and over again. So it's kind of like, again, that concept of creating a recipe or a spell. Once we've created that, we can just call it by name with one single simple thing. So notice back here, this could have 100 lines, and now to use those 100 lines, I can just put myfunc in the program and it will call it. And notice that that greatly simplifies things. Also, for maintainability, if we wanted to change what the function did later, or it had a bug in it, rather than hunting down 100 different places where we did that action or caused that behavior, we could change it once in the function and that'll fix it. Or for optimization, you might write a function and then you said, you know, there's a better way to do what I did before. Rather than having to hunt through my code and find all the places where I did that and change all those, I just change it one place in the function, and now everything works better because I made the function work better. It can also shorten your code, meaning that because we're getting rid of repetition or redundancy, we can make our program much less lengthy, to make it shorter, and that means less code to maintain, less code to have to wade through when you're working on adding things or fixing things or debugging. And so it's just functions are an organizational tool. And that can be a really powerful organizational tool. All right, the second reason to use functions is for this concept of abstraction. Because we can give the functions a name, we can call them by name. So in our code, you could call a function called, give it a name like clear screen. And then when you're reading the code, you can see the words clear screen, and you'll immediately know what that did. So if you gave that function a good name, one that was descriptive, clear screen, then when you see it used, you know exactly what it means. And that's the concept of abstraction. So rather than thinking of something in terms of its implementation details and all the steps necessary to do that, you can think about it as what it's actually doing, clearing the screen, firing lasers, whatever. And that allows us to use functions without really knowing or caring how they work. So think about the print function. We don't really care what it does. We just care that it prints stuff out for us. And when we see that in our code, what do you think the print function does? Probably prints things. What do you think the time.sleep function does? It probably sleeps for a little while. And you don't have to worry about how it sleeps or why it's written the way it is or all the details that go into making it do what it does. And if you open up that random.randin, what do you think the randint function does? Probably gives us a random integer. We can tell that by its name. But if you open it up and look at how it actually generates those random numbers, it can be very complex, have a lot of details, a lot of implementation there. We don't care about that. We just want a random integer, so we can call random.randint. That being said, function names should match the abstraction of what they're doing. So for example, let's say you're writing a game and there are lasers that get fired. You might make a function called fire lasers. And when you see that in your code, fire lasers, you know what it is. Compute damage, what do you think that function would do? Probably compute the damage that was done by some attack. Lose rings, what do you think that would do? Maybe a Sonic the Hedgehog game. Well, all of the rings would go blue, 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 and fly out of Sonic when you run into some thing or take damage. Distance, what do you think that does? Probably computes the distance. You might even make this better and call it compute underscore distance, or distance underscore between underscore points or something like that. So One of the things, though, make the function names match the abstraction, make them descriptive, but don't make them overly descriptive for no reason. So, for example, you probably don't want to call your distance function this underscore function underscore computes underscore the underscore distance underscore between underscore two underscore points underscore on underscore the underscore screen. You probably don't want to call it that because you're going to have to type that in every time you want to use it. And then that's more visual noise to look at. If a concise name like fire lasers, compute distance, or just distance works, then go with that. And the end result of having this abstraction, it allows us to write code that's easier to read. You can say, okay, when I take damage, what do? I fire the lasers. How do I know if I take damage? Well, I would compute the damage and I would compute the distance. And if the distance was below this level, meaning I was too close, and I called compute damage and got this result, then I fire the laser. So your code will look like the idea of what it's doing rather than a whole bunch of low-level implementation details. And that can make your code easier to read, easier to write, and easier to debug and maintain later on when you want to make changes. All right, the third reason for using the functions to organize your code are it allows us to create our own libraries of functions. So we could collect a set of functions together. Let's say we're making a game that has some sort of AI in it. Well, you could collect those together and make an AI library or an AI module. And once we've made that module, we could use it not just in this program we're working on, but a future program that we're working on. Think of Pygame. Think of all the games you could write with Pygame. Well, it has the ability to draw circles and lines and create a screen and get keyboard input and mouse input. All that's collected together for us by somebody else, but we could make our own library like that that does graphics things and input things and AI stuff and physics stuff. We could gather all that together and make our own library or libraries and then use them later. Right now, we're going to define our functions within our programs that we write, but later on, we're going to look at how do we make a module of that we then call to do things. All right, so here's a simple function example that uses abstraction. So notice here's the actual function, def clear screen. And here's the detail. It only does one thing. It just does ds.fill 000, so it clears the screen to black. But notice now in my program, when I see that, rather than saying ds.fill, I know I can read the program and say, what do you think it's doing on that line? Well, it's obviously clearing the screen. That makes sense now. And so even if you're just doing a one-line function like this, it can still be useful because of the abstraction. It makes the code look like what it's doing. But this, when I define this function, that's not actually executing it yet. That's not clearing the screen there. It doesn't clear the screen until we call the function. And notice to call the function, we need to put parentheses on it, even if there's nothing in the parentheses. Clear screen invokes the function, just like pygame.display.update causes the screen to be updated, just like pygame.display.quit. Notice whenever we call a function, we're going to have parentheses. And there might be something in the parentheses, or there might not. Depends on how the function was created. So there's where the function's defined. Here's where the function is called. And one thing to note is that a function has to be defined before it actually gets called. All right, sorry about that. Okay, now, next thing that we're going to look at is function parameters. So notice, going back to this example, notice that some functions like pygame.display.setMode, they're things inside the parentheses in here. Or another example there is ds.fill. We have sending data to that function. So sometimes we want to make a function that needs things to tell it how to do what we want it to do. So for example, here's an example here, draw a face. You want to say, define this draw face function. Well, you might want to say, where do we want the face drawn? What's the XY position on the screen where we want the face to be? And those things that we pass to the function are called parameters or function arguments. I usually use the word parameter. Some people call them arguments. Sometimes I'll call them arguments too. But those mean the same thing. But the idea there is, in the function definition of draw face up here, we're saying that this function needs two different arguments or two parameters to do what we want it to do. It needs an x and needs a y. And when we call the function, we're going to give it 2 pieces of data because it requires 2 pieces of data. The drawFace function needs 2 pieces of data. The first one is going to be referred to as x. The second one as y. So when I say drawFace 100, 100, I'm saying I want you to draw a face at position 100, 100 on the screen. But when this function gets called, this 100 is going to get associated with the name x. The second 100 is going to get associated with y. And I could put variables in here or expressions in here. So if I said drawFace player underscore x, player underscore y, whatever was inside the variable player x is going to get passed in for x. Whatever is inside of this variable player underscore y is going to get passed in for y. And those variables are going to be assigned the values by position. In other words, inside the function now, though in this case here, x is going to be equal to 100, y is going to be equal to 100. So we can now access those variables, which will have the values that were passed in. And by default, the parameters are passed by position. So note that when we call a function and pass data in for the parameters, oops, let me fix something here. And pass data in for those parameters, like we did here, player underscore x, player underscore y, the parameters are positional. In other words, whatever piece of data I put first is going to get associated with the x. Whatever piece of data I put second is going to be associated with the second name. So whatever variable names we put in our definition are going to get associated with the whatever data we pass in the order that we passed it. So the first thing I pass gets associated with variable name 1. The second thing I pass gets associated with variable name 2. The third thing, you can also pass them by name. So when you call the function, you could say drawFace x equal 200, y equal 300. Or we could, if we use the names like this, the position doesn't matter anymore. So I could say y first and x second. drawFace with a y of 300 and x of 200. And notice when we name the parameters like that and define them this way, the position, that overrides the positional behavior. So we can put them in a different order. But if we just put numbers in, like we did back here, 100, 100, the position goes in the same order. X is equal to 100, y is equal to 100. All right, we can also define our function such that it has default values, which makes the parameters optional. So for example, if my function definition looks like this, def drawFace x equal 400, y equal 300, that means if I don't provide a value for the first position, and I don't provide a value for the second position, it's going to use a default. X is going to default to 400, y to 300. So if I were to just call this function drawFace with nothing in the parentheses, it would still have an x and a y. It would just use the default values. So if no x value is provided, a 400 would be used. If no y value is provided, a 300 would be used. But if I did provide an x and a y, it would override those defaults and adopt the values that that was given. Okay, function return values. Functions can produce a resulting output, and that means the function acting like a little program, you can call it, it can produce something and return that to us. And notice we've used that several times, like the CHR function or int function or float function. We're passing something in, it's giving us a result back. And this is a really common way to use functions. So here's an example of doing that. So we've defined a function called average2. We passed in 2 pieces of data, an a and a b. And what this function does is it says add a to b, divide it by 2 to compute the average. That produces this variable result, return result. So notice this keyword return is something new that we can only use inside of functions like this. But that says as soon as I hit that return, it's sending that value, that result back to us, whatever that computation was. So all functions return some data item. Functions can only return a single data item. It could be a list or a tuple, so we can make a function that returns a color that has red, green, and blue component, or a list of a whole bunch of things we'll look at. We haven't talked about lists or sequences too much, but we've seen tuples in the form of red, green, blue colors. And the return statement, when it encounters that, causes the function to immediately exit and produce this as its result, whatever we have there. This doesn't have to be the word result. It could be return whatever variable we want. This is just a variable name. The value returned from the function replaces the function call where the function was called from. So in other words, if I say compute the average of these two numbers, 10, 20, that's going to compute that as 15, and then that 15 is going to be sent back and replace the actual function from where it was called. So that function is going to produce a value of 15 at that point. And if no return value is specified, in other words, if I don't have a return statement, I leave it out altogether, and the function gets to the bottom of the indented code and there's no return statement, it still returns something. It just returns a special type called none. Just like there was a special capital T true, capital F false, there's a capital N none, which basically says this function returned nothing. So none is a way to represent nothingness. It didn't return anything. It didn't return true, it didn't return false, it didn't return a number, it didn't return a string, it actually returned nothing, none. And that happens automatically if you don't. You could also return none directly if you want. You could say return none, but if you leave it off and don't have any return, the function will still return none. All right, now we're up to a little mystery here. And I'm going to pause the recording for just a second. We'll pick this up in a little bit, because once we get through this mystery, I'm going to talk a little bit about the lab, and then I'm going to turn you loose on that. But I'm going to pause this, and we'll be back shortly. Okay, I'm back. Let's look at the way variables inside of functions work. And there's a little bit of a mystery here that we're going to solve. So here's a little bit of code. Let's say we wrote our code where we have this gold variable. We set gold equal to 0. Somewhere in the program, they pick up a chest and they get 100 gold pieces, so gold plus equal 100. Somewhere later on, they get robbed by a thief. Gold goes to 0. And then somewhere they print out how much gold they have. Well, we decided we want to write functions for that. So we want to have something that basically lose gold sets it to 0, get gold adds 100, same code there, and then show gold will print out how much gold they have. So we've kind of abstracted that. We lost our gold, we picked up some, we look at how much we have. So we use those functions. And then in our code, we basically start off gold at 0, we show it, we get it, we show it again, we lose it, and we show it. So what we would think would happen is gold starts at 0, we show it, should say you now have, or you have 0 gold, and then we get gold, which should add 100, and which point we would now have 100. When we show it, we'd say you have 100 gold, and then we lose it, we get robbed, and gold goes back to 0, and then we show it, and we would say you have 0 gold again. So the mystery here is this doesn't work as we would expect it to if we wrote this code after we define these functions. Here's what actually happens. Gold equals 0, show it, that actually works. It'll say you have 0 gold. But then when it hits this line for get gold, we're going to get an error. It's going to say variable referenced before assignment. But how could the gold variable be referenced before assignment when it already existed? We created it there. So let's say we comment that line out temporarily. Show gold here would work again. Lose gold here would actually run and not crash the program. But when we show it again, we would not have the right value in it. We would not have the 100 that we added, would have added from up there. So why doesn't it work as expected? And the answer to that, we're going to answer here in just a second. So the reason it doesn't work is that, and the answer to that is from inside a function, global variables can be seen, but not modified or changed. In other words, if I'm just looking at a variable, like we have down here with show gold, that'll work fine. It'll print out whatever's in that global variable gold. But this thing here where I say gold equals 0, that's creating a new local variable that's just active inside this function, and it's setting that to 0. It's not affecting the original one. It's creating this new one that's only for this function to use. And down here, gold plus equal 100 says, hey, my function doesn't have a gold variable anywhere in here. So there is no local function, no local variable inside this function called gold, and that's where we get that error. All right, so let's look at how we would, how we're going to look at this. So there's two things that go into this code, and let me go back to that code for just a second here. So if you look at the code, why is that a problem? Well, because variables that are created or accessed to be changed inside a function have to be local to that function. But globals can be looked at. And that comes down to two different things. There's a thing called scope, and there's a thing called lifetime. Scope defines where a variable is visible, inside of the code, and lifetime defines how long a variable retains its value. And variables are created in the main part of the program are called global variables. They retain their value until they're destroyed or the program ends. They can be seen from anywhere, including from inside functions, but they can't be changed from inside functions unless the function is granted permission to change them. And we'll talk about how to do that in just a second. But variables that are created in a function are local variables. They only retain their value while the function is running. They'll immediately be destroyed when the function returns. And they're only visible from inside that function. And I'm going to go and pause for a second. I'll be back in 1 second. We're going to go over this, but there's a really good analogy for how this works that will help you think about it. We'll cover that here in just a second. Okay, so back to scope and lifetime here. Now, why is the default to disallow the modification of global variables from within a function? And that question comes up. Is that like a bug or an oversight? Why did they design it like that? And the answer is that it was done on purpose. And the reason for that is you don't want to have some recipe that you use or a spell that you invoke that causes bad things to happen and unexpected things to happen to other parts of your program. So imagine you had a function that you wrote that used a variable, let's say I, or health, or result internally, and that screwed up something in your main program. You don't want that to happen. So the idea is that the default behavior is that to not allow that accidental modification to happen unless you explicitly tell it to. So think of it kind of like a car, that you're in your car, you can do whatever you want to the things that are inside of the box of your car. You can turn on the radio, you can turn off the radio, you can take a knife and tear up the dashboard if you wanted, you could light things on fire. It's your car, you can do whatever you want. That's like the inside of a function. You can look out the windows and see things that aren't inside, but you can't change them. Like, for example, you could look out the window and see a tree, but you can't rip leaves off it or change it by default. So you're inside your car, the windows are rolled up. You can do anything you want inside of that function. You can create stuff, you can destroy things, you can overwrite stuff, you can modify to your heart's content inside your own car, and you can look out the window and see things in the real world and get the values of them. You can read a billboard, but you can't change the billboard from inside the car. Now, the idea, though, is that there are cases where you'd want to do that. You can roll down the window to access certain things, like an ATM keypad. You roll up to that, you roll down the window, you reach out, and you interact with something in the outside of that environment. Now, the way you do that is by using this special, if you want to modify a global variable from inside of a function, you just put the word global space and then the name of the variable you want to be able to access from inside that function at the top of that function. So for example, if we wanted to fix that program we had earlier and make it work as expected, we just add global gold inside of the lose gold function. We add global gold inside of the get gold function. And that says rather than using a local variable here, use the global one. And we're saying that with this statement. So the global statement allows us to tell a function you're okay to modify this variable, but we have to explicitly state which global variable we want it to access. Functions can also never modify variables inside of other functions unless they're both global. And the reason for that is obvious, because the variables of a function only exist while it's running. The lifetime is only function lifetime, meaning as soon as that function completes, all of its variables lose their values. Okay, so let's take a quick look at Lab 5. In Lab 5, you're going to be writing some functions for yourself. Distance, x1, y1, x2, y2. In other words, this is a point. That's a point. We want this function to compute the distance between those 2 points. How far apart are they? You'll use the distance formula for that, which is essentially the Pythagorean theorem. The square root of the difference in x's squared plus the difference in y squared. You're going to write code that does that and then returns that value back. And then you're going to use that to write the code for the function. You're also going to write this draw player function that you're going to pass an x and a y to. And that's going to draw the face of the player at that position on the screen. Draw target is going to pass an X and a Y to it. It's going to draw the target at that specified position. And then draw background. We don't have to pass anything to that. It's just going to draw. It could just be clear the screen to black, or it could be clear the screen to black and draw some things. It could be make stripes. Well, however you want the background to be. We'll talk about that in a second. So your main program then is going to call one of those four functions, or those four functions in different places. You're also going to need to use font output to create a heads-up display with UI elements that show the time remaining and the score. And the way you should go about writing the code for this should be an evolutionary process, meaning that get one part of it working and then add a feature, and then get that working, and then add another feature and get that working, and just keep adding features until everything is done. There's also a chance on this lab for a considerable amount of bonus points. So if you want to bank some points for the midterm, or you want to get a little bit of extra points to make up for some points on quizzes or previous labs, this is a good time to do that. So let's take a look at the actual lab sheet. Let me go ahead and pull that up quickly here. Let me switch over so you can actually see what I'm doing here. Let me zoom in. Whoa, too far. All right, there we go. So here's what we're going to be doing for Lab 4. Or is this Lab 4? Lab 5. So for Lab 5, you're going to actually be making a real game, and you're going to use functions to do that. So here's an overview. You're going to write a distance function, a draw player function, a draw target function, a draw background function. And then after you write those functions, you're going to and read the details about these. In other words, the draw player function, you want it to draw this kind of draw player function such that it'll have a face. And mine, I made it like a college student, and we want, if the player gets close to the target, we want to make the player look excited. And I want you to use at least 8 Pygame drawing objects. So it might be a circle for the head, circles for each of the eyes, some lines for the nose, a line for the mouth, whatever. Don't use graphics, images, even if you know how. We talked about that last class, but don't use those. I want you to use drawing objects for this. And then draw target. My target, I made a little beer mug. You can use anything you want. It could be a treasure box or a gold coin with a dollar sign in the middle of it. It could be a money bag. It could be donuts. You can make your player a police officer, and the target's donuts. And you just go around and get those. It could be a Teenage Mutant Ninja Turtle for the player, and pizzas as the targets. It's up to you. Be creative and have fun with it. And the background, all you really need to do is at least clear the screen to some color for the background. Now the game loop, it's gonna run for 60 seconds, or until the escape key is hit. And remember, we have the time dot import time, and then time will give you the number of seconds that passed since the January 1st, 1970. Or there's another thing you can do here, and that is there's a Pygame time function, pygame.time.getTime, that returns the number of milliseconds passed since the game had started. So you could use that. So you want to keep running that until 60 seconds worth of time has elapsed. And if either of those things happens, then the game ends. And then inside of that game loop, you're going to draw the background by calling the draw background function. You're going to draw the player and the target by calling the draw player and draw target functions. And then you're going to have some if stances. If the player touches the target, the way you're going to do that is by checking their distance. So if you check the distance from the player to the target and it's below a certain amount, then they're touching. And if it's below that certain amount they're touching, then you want to randomly move the target to a new position and add a point to their score. You'll use the WASD keys to move the player around. You don't want the user to go off the screen. And you want it to display the current score and the time remaining rounded to the nearest 1 decimal place. So it'd be like 10.1, 10.0, 9.9, 9.8, and you'd see it counting down. After the game loop, if the time ran out, then you want to display a game over message and the player's final score on the screen for 3 seconds. If the escape key was pressed, then we just want to immediately exit without any other kind of message. So you have to kind of plan out how to get this working. And as an example for what this might look like, here's what my game looked like. Here's the my draw player drew that. Here's my draw target drew that. You'll move this around. When that touches that, this will go up by 1, and the time will count down all the way down to 0, and then the game will end and print the final score. Time remaining will be 0 at that point, but it'll say beverages consumed. Maybe you got 10 in the 60 seconds that it ran. So in other words, you just have 1 minute to collect as many things as you can, and if he touches that, then that disappears and it shows up in a new random place on the screen. So that's the game, and the objective is to collect as many of these as you can in 1 minute. All right, now here are the bonus features. You can animate the player. So I made the face blink every once in a while, so this would actually kind of, the eyes would go from circles to little lines, back to circles, so it would look like blinking. You can animate it however you want in your thing. So if you wanted it to be animated where it kind of blinks, or you might want to animate it where if it's something that's like spins, whatever you want, it's up to you. That's worth 2 points. If you animate the target, then that's worth another 2 points. In mine, I actually made the beer bubble, so these little bubbles kind of rise to the top there inside the beer mug. You can make your animation however you want it. If you had a coin, you can make it look like it's spinning. If you had or you can make something that looks like it's rotating. It's up to you, however you want. For 3 points, add an obstacle. It could be just a rectangle, like a box that's in the way that you have to kind of go around to get to this. It doesn't have to move. It could just be a rectangle on the screen. And you have to keep the player and the target from getting into that area on the screen. So if there's a box in the way, the player should run into it, have to go around it to get there. If you wanted to make it a little more complicated, you could make the obstacle more like a little maze or something. It's up to you for however you want to do that. And then it's worth 3 points to make the target wander around the screen randomly. So we don't want to let it leave the screen, but it would wander around. So in other words, this thing might kind of wiggle around on the screen and move. So let's say this was the target. It would kind of wander around the screen like this. And here's the player. And the player would get one, disappear, show up somewhere else. Player who goes and gets that, disappears, shows up somewhere else. Player gets that, disappears, shows up somewhere else. And so forth until the 60 seconds is out or they hit escape. All right, so that's the lab. A couple of hints here. Use the Pythagorean theorem for the distance function. And for the font examples, look at the previous lecture for how to do fonts on the screen. It might take some experimentation to get them to show up in the right place. And also for this counting down, there's one thing that I want to mention of how to do that. The font functions can only print strings. And so in order to get that to show up like that, where it says, for example, beverages consumed, :2, you're going to want to make a string that looks exactly like this. And the way you do that is you might say font.render, and then the part you're going to have, quote, beverages consumed, end quote, plus str of score. So that's going to take the number that's in the score variable as a number, convert it to a string, and then the plus sign concatenates the two to add them together to make a bigger string. That's what's going to go to the font function. The same thing is going to be true for what you send to this function here. The other part for how to round this to the nearest tenth of a decimal point, I'm going to give you a quick hint on that as well. There's a couple ways to do that. One of them you could use Google and look up Python format strings. That would be one way to do it. But there's another way too that's kind of clever, and that is if you take 42.1 and then there's a bunch of other stuff here. If you multiplied that by 10, you'd get 421. And then if you take the integer of that, or 421 point something, if you took the integer of that, you get 421. And then if you divide that back by 10 again, it moves the decimal place 1 over, you get 42.1. But I'll leave that up to you to look at that. The format strings is probably a better way to do it. So if you want to Google that and look that up, do that. Another way to do it would be to print this out and somehow, or convert this into a string, and then make sure to cut off the stuff after the tenth of a decimal point, or the 10th place of the decimal point. There's a bunch of ways to do this. Some of them are good, some of them are not. Some of them are better than others, I should say. I guess it's good if it works, but it's better if it is a little more elegant. But there's a way to do format strings to format things to get just a tenth. So try to Google that and look that up. And one of the things, the reason I'm not telling you exactly how to do that right now is a big part of learning to program is to be able to, when you're presented with a problem, is to be able to use resources like the internet or the Python documentation to look up, how do I solve that problem? How do I figure out how to get that to do that? And so what I would challenge you to do is see if you can figure that out. If you get stuck and can't figure it out, let me know. Send me an email, send me a text message, or if you need to, I can come in and have office hours or come in during class time and help you with that. So that's it for today. For the rest of the class, go ahead and work on whichever lab you're on. I'd get started on this one. It really doesn't take a lot of code. There might be some experimentation needed to make the character look how you want. Although you have a pretty good head start on that from your last lab where you were drawing the face. You'll just have to add variables so it can move around to different positions. And there might be some experimentation to make this. But remember, it doesn't have to be a beer mug like I made. This could be relatively simple if you wanted. It could be a coin. So that could be a yellow circle with a $ sign on it. Or it could be, I don't know, a Pokemon ball. It could be whatever you want to draw that as. It could be a Pac-Man ghost from your previous thing, and this character could be a Pac-Man that you run around and eat the things. It's up to you. All right, so go ahead and work on that. And let me switch back to the presentation just for a second here. And kind of finishing things up here with where we are in this is work on the labs. That's it for today. Wash your hands, wear a mask if you go near other people that aren't in your immediate social group or household, and stay safe. And next class, I'm going to announce the midterm and give you some lab time as well. So, and I'm also going to post the midterm study guide. So everybody stay safe and look for that next class. So that's it for today.